This is a question from a CCEA Maths AS Pure past paper, and it's from 2021, and we're looking at question 7. So let's take a wee look. Now I've kind of done part of it already. So it says first of all to differentiate this. This isn't quite an awkward form to differentiate, so I'm going to rearrange it. I'm going to let y equal this function first of all, and then rewrite them all in the form ax to the n, where a is a number, x, and then some power. So this one here, so I'm just going to rewrite that then as a fifth x. Here the x squared is on the bottom, so I'm going to bring it up to the top, so it's 3x to the minus 2. And here that's x to the power of a half, but again it's on the bottom, so I need to bring it up x to the power of minus a half. A lot of people bring the 4 up there as well, just be careful of that. So it's minus a quarter x to the minus a half. I'm now ready to differentiate, so dy by dx is then going to equal a fifth. The x disappears. Here, take away 1 from the power, so it goes into the power of minus 3. Minus 2 times 3 gives me minus 6. Here, take away 1 from the power, minus a half minus 1 gives me minus 3 over 2, and then multiplying by the old power, minus a half times minus a quarter gives me an eighth. Just to tidy these up a little bit then, a fifth, bringing the x back down to the bottom, is minus 6 over x cubed, and again bringing the x to the minus 3 over 2 down to the bottom is 1 over 8x to the power of 3 over 2. On then to part B. Shows a sketch of plans for a display area in a garden centre. Display area has a rectangular lawn with 2 quarter circles of soil, one on either side. The lawn has a length of x meters. Each patch of soil has a radius of r meters. The perimeter is 32 meters. Express x in terms of r. So we've got to find the distance round here. So we're going to have r plus x plus r plus x, and then our 2 quarter circles. What are those quarter circles? If that's r, all the way round would be 2 pi r. So only we want half of that. We want that one plus that one. So it's going to be then kind of pi r. So we're going to have 2x, that's this plus this, part of the perimeter, 2r, this plus this, and then pi r, which is our half circle. We know 2x plus 2r plus pi r equals 32, so that's my next line. And then it says express x in terms of r, so I'm going to rearrange that then. 2x on its own, 32, taking these two things over to the other side, and then divided by 2, 32 minus 2r minus pi r all over 2. On then to part 2. Part 2 says, hence show the area of the lawn, a meter squared is that. So our a, and it's the area of the lawn we're just looking for here. So the lawn bit is just this bit here, and it's x, and that's an r. So that's going to be x, r. The x that we have, because you notice here in what we're looking for, there's no x there, so we use our previous part to do that. And here's our previous part, if you remember it, 32 minus 2r minus pi r over 2. So I rewrite this then as 32 minus 2r minus pi r all over 2 all upon r. So that's going to give us 32 over 2 times r, that's 16r, minus 2r over 2 times r, so the 2's actually cancelled there, and I'm left with minus r squared, and then pi r squared over 2, so it's minus a half pi r squared, and that's what we were looking for. Part 3, using calculus, find the exact value of r for which the area of the lawn is a maximum. So we need to then maximize this lawn, so we need to differentiate here. So it's going to be dA by dr. So differentiating this then, let's take a wee look at what it is we're differentiating. If I set this, hopefully you can then kind of see both. Slide it up a bit so we can see where we're going to differentiate the 16r. I get a 16. minus 2r, and then here is then minus pi r. To find a maximum, then dA by dr is equal to 0. So that means 16 minus 2r minus pi r is equal to 0. So we want to solve this then for r. So I'm going to take both of these r's to this side and factorize them out. So it's going to be 16 equals 2r minus pi r. 16 equals r upon 2 minus pi. So r then is 16 over 2 minus pi. And it says find the exact value of r. And by exact there they mean leave it in terms of pi. So that's my answer there. That's what we're looking for. Okay. You also need to show obviously that it's a maximum. So to do that we need to find d2a by dr squared. So we need to differentiate then this term here. So the 16 disappears and we get then minus 2 minus pi. That is less than or equal to 0 as in thing. Therefore it is indeed a maximum, which is what we want.